Alright, today we are looking at tangents and normals.
Do you mind if I send the sermons class? Because I'm going to have my friend here.
Alright, so if we have a curve like that, then, and I've got some point, say this point there, then I can draw two lines, and well, I can draw lots of lines, but two in particular. The blue one here, that one
Tangent.
is the tangent. And so that touches the curve in one spot. And the gradient of the tangent is the same as the gradient of the curve at that point. The normal is a line that is like this, and the relationship between the normal and the tangent is that they are at right angles to each other. So, if we want to find the equations of the tangent and the normal, there's a few things that we can use to help us. So we would need to know that point there. Let's call it point P. Got some x and y value. So if I was wanting to find the equation of either the tangent or the normal, there I would need to use certain information. And so the useful things for us, oops, can't spell. So the useful things are the gradient point form of an equation. So the gradient point form is y minus y1 equals m x minus x1. The other thing that is useful to us is that the gradient itself is equal to m, which is also, of course, the derivative at that particular point. And the other thing that is useful for us is that since the tangent is perpendicular to the normal, then the gradient of our tangent times the gradient of our normal has got to equal -1. All right. So we will be given the equation of that curve and asked to find tangents or normals somewhere on the curve. All right, so let's look at some examples. Alright, to rub that off.
Yeah.
It's not the since tangent part.
Alright, first equation, example. So we've got the equation of the curve, it's cubic, and we're asked to find the tangent at the point where x is equal to 1. So we need two things. So we need the point and we need the gradient. So the point, we have the x value. To find the y value, we just need to substitute. So add x equals 1, y equals 1 cubed plus a half times 1 squared, which would be 3 on 2. Yep. So our point is 1 and 3 on 2. All right. We need the gradient, and it's the tangent we're looking for. And so the gradient of the tangent is related to the derivative. So dy dx is what? 3x squared plus 1x. Now we're looking for it at a particular place, and the place that we're looking for it at is x equals 1. Yep. So the gradient of our tangent is 3 times 1 squared plus 1, which is 4. Yeah. Alright, so now we have the information we need. Gradient point form. Y minus y1 mx minus x1. Y minus 3 over 2 equals 4x minus 1. A bunch of rearranging, expanding, rearranging, times by 4 everything on the right, I should say. Get that. Add 3 on 2 to both sides. Minus 4 plus 3 on 2 is the same as minus 4 plus 1.5. So that's minus 2.5, isn't it? Which would be 5 over 2 or some other variation.
Is that the end answer?
Hmm?
Is that the end answer?
That's the end answer. Oh, sorry. All right. I'll rub the top bit off. Okay, so if we want to find a normal, so let's have a look at All right. So with all of these, we need two things. We need a point and we need the gradient. Point, we've already been given that, so we're already told that it's 1 and -1. The next one is the gradient. The gradient of what? We want the gradient of the normal. So, what do we know? Well, we know that the gradient of the normal times the gradient of the tangent is equal to -1. So if I then divide both sides by the gradient of the tangent, the gradient of the normal would be -1 over the gradient of the tangent. So what we need to work out here then is the gradient of the tangent, and we can do that because we know that the gradient of the tangent is connected to the derivative. Alright, so dy dx is 3x squared minus 4x, I think. Am I right there? Now, a particular point we're interested in is when x is 1. So the gradient of the tangent, which is dy dx at that point, 3 times 1 squared minus 4 times 1, which is
-1.
-1. So then the gradient of our normal will be -1 over -1, which is
1.
and so y minus y1 equals the gradient times x minus x1. So y minus -1 equals 1 times x minus 1. So the final answer would be
No, -2.
-2. Yep, got to take one from both sides. All right. All right, any questions so far? If I've gone too quick on. I'm all right to rub this off.
It's not the part that it wasn't.
All right, so this of course works for any type of function. I've just used polynomial ones there. So let's find the equation of the normal. Not the normal, got to say the tangent. So just because it's a circular function, trig function, doesn't change what we need. We still need a point, which we're told is pi on 2 and 0. And we still need, excuse me, the gradient, and this time it's the gradient of the tangent we're after. And the gradient of the tangent is related to dy dx. And when we differentiate that, what do we get? Got a negative there, which is that. When we differentiate cos, we get just sine. Just sine x.
Oh, is it negative?
Is negative sine x. And then those two negatives cancel. So it's just sine x. So we want to know, of course, at a particular spot, and that's when x is equal to pi on 2. So the gradient of our tangent is the sine of pi on 2, which is
One.
1. There's our circle, pi on 2 is up here. Sine 1. So for our tangent, y minus y1, then bracket x minus x1. The y value, 0. Gradient's 1, x. The x value of our point, pi on 2. And so there's our equation. Anything there that anyone's not happy about? No. So yeah, don't let things like, you know, pi's on 2s and stuff like that distract you. It's still the same process that we're looking for. Still looking for a point, still looking for a gradient, still putting them into here, and then whatever we end up with there is what we end up with. Remember, pi on 2 is just a number. It's an irrational number, greatly long decimal, but still a number. All right. One more example. All right to rub that off? Alright, so this is a root graph, cubed root graph. Still need the same stuff. Still need our point. We still need our gradient. So we have x equals 0, find the other coordinate, will be f of 0, which is 0 to the 1/3, which is
Oh, I did
0.
not see that.
So point is that we're looking at is 0, 0. And, alright, at the origin. Alright, the gradient. So the gradient of the tangent is related to the derivative. And seeing as it's been written in function notation, I'll use f dash. Be consistent with our notation. Alright, so what is the derivative of this? Bring the power down, 1/3, reduce it by 1, so it's now going to be
Negative.
-2/3.
Sorry.
Alright, now, when x is equal to 0, so the gradient of our tangent will be 1/3 times 0 to the -2/3. Alright. What does this minus?
Means that you can put it in a fraction.
We can put it in fractions, so we can write 1 over 0 to the 2/3. Oops, forgot one.
Yeah.
Now, what is 0 to the 2/3? 0. So we've got 1/3 times 1 on 0. Does anyone see any problems?
Yeah.
Dividing by 0 over here, so what does that mean?
It's undefined.
It means it's undefined.
Was that intentional?
It was intentional, because I want to highlight something. So what does that mean about the tangent to this curve at this point?
It's straight, isn't it?
It's not right angle. It's the same thing.
Right, so we've got an issue, haven't we?
What does it mean?
What does it mean? So if that's undefined, Nicole was on the right track there. Vertical line is correct, because the vertical line, the gradient is undefined, isn't it? Undefined gradient. Means vertical line. Okay, so a vertical line that goes through the origin, well, all vertical lines, what's their equation?
It's X.
X equals, yep, vertical line, so x equals something. And so in this case, x is going to be equal to 0. Alright, so visualise that. What does that? If I have a graph, and this is to the power of 1/3, like I said, it's a cubed root graph. Now all root graphs go like this. Square root would go like that, and you can only have that, but because this is an odd power, we can have the other half of it goes like that. So
Is it supposed to be even?
it's supposed to be even, yes. I'm not a very good artist. So, and we've said here undefined, so the tangent is that, and that kind of makes sense, doesn't it? Now when you look at the graph, yeah, that would be kind of vertical and it curves around. So tangent is that one there. All right. So yes, I did choose this purposely, just to highlight that that actually means something in this context. This context, I found that the derivative was undefined, but in this case the derivative is the gradient of the tangent, undefined gradient vertical line. All right, anything else? Everyone's happy? Oh, good on you, Jed. That was nice. Good to hear that. All right, don't forget, like and subscribe.
Good fun, yeah.